All right. Today, we're going to talk about a topic of how to generate an SBOM, a software bill of materials, with free open source tools. So we'll just kind of get moving. My name is Josh Bressers. I am the Vice President of Security at a company called Anchor. We are a kind of next generation supply chain company, and we have a lot of focus on software bill of materials. And we have some open source projects. I'm going to specifically talk about those today. But I'm Josh. I do a lot of outreach. I do a lot of vulnerability work. I've got a couple of podcasts. I've got one that's called the Open Source Security Podcast. I do a podcast called The Hacker History. I'm on like all the socials at Josh Bressers. I love talking about this stuff. So by all means, reach out, say hi. I will talk your ear off about most any security topic you can possibly imagine. But this stuff's a lot of fun, so I'm really excited to share it with you today. So let's just kind of start out our conversation with what is an SBOM, right? Software bill of materials. If you've been in this space for any amount of time and you've heard about a software bill of materials, an SBOM, often the comparison made is an ingredients list, right? Like I took a picture here. This is literally a picture I took because I couldn't find one I liked, of a can of it's spaghetti sauce, I think. And obviously there's ingredients. And I picked out tomatoes specifically. And there's a good reason for this, because when we think about our ingredients, when we think about the things in our software, like what is an ingredient, right? What do we mean when we say that? And I think tomatoes is a great example, because what is a tomato, right? When most of us think of tomatoes, this is probably what comes to mind, right? Like a nice piece of fruit or vegetable, whatever you want to call it. I won't get in that argument. Growing on a plant, right? They look great. They taste great. Everyone loves them. But the reality is, this is what tomatoes are for a lot of us, right? But remember, our ingredient just says tomatoes. Is it this? Is it this? Or is it this? And so that's what we're going to kind of talk about today, is how do we go from an ingredients list into an explanation of what is in our software? So now, what is an SBOM? When we say SBOM, we're really talking about these two data formats. One is called SPDX, the other is called CycloneDX. Now, you could, of course, get into arguments, which is better. They're functionally the same thing. SPDX and CycloneDX are both internationally recognized standards. They're open source projects. You can get involved. You can pay attention to them. SPDX is run through the Linux Foundation. CycloneDX is run through OWASP. But at the end of the day, the thing they accomplish is basically the same thing, right? Where you somehow collect an inventory of your software and you put it in a machine-readable format. And we'll kind of talk about what that format is in a little while. But fundamentally, if someone says, I want an SBOM, what they're going to mean is one of these two formats. And now, which one? That's the question, right? You'll find that some organizations will say, oh, we only want SPDX. Some will say, I only want CycloneDX. Most won't ask for both. Some might. But generally speaking, you'll find that every organization looking to do SBOMs has settled on one, just because it's easier to deal with one format instead of both, right? Obviously, that's just the reality of computers. So when do we create these things? And now, this is one of the fun topics that come up with SBOMs, because there's different kind of times you can do it, right? Are you generating SBOMs from your source code? Are you generating SBOMs while you're building software? Are you generating SBOMs after you build to the thing you're going to distribute to your customer or put on GitHub or whatever you're doing? If you're the consumer receiving a thing, are you generating an SBOM to see what's inside of it? And I stole this graphic actually from Salsa, which is like a whole other open source project on supply chain security. But the graphic does, I think, a nice job of kind of simplifying the various stages of software development. And so from our perspective, I'm thinking of us as like the consumer, right? We're the person at the end. And so we're going to do some talking about what that means and what we can do to generate a software bill of materials kind of as a consumer. You know, maybe if you're a distributor, you're going to be over here. That's a little different. It's very similar. But once we get into like build and source, things get quite a bit different. And what I mean by that is like when you have a pile of source code, what are you scanning? Are you scanning just your source code? Are you scanning your source code plus all the dependencies it's going to pull in? Like you don't always know what those dependencies are. An example being if I install a package right now from, let's say, NPM, we're going to show off some NPM stuff later. If I install a package from NPM right now and there's an update in an hour, and then I install my package again in 2 hours, I might get a different version. So there's a lot of weird challenges that happen in some of these stages. Build is another good one. If I take my source code I put it in a container. Now there's the stuff that was in the container, right? That's some new software. It's different. So the thing I generated over here in source isn't the thing I'm going to generate during the build necessarily. It might not be the thing generated during distribution because maybe I add some things before it goes out the door. Like, who knows? There could be customization. And then when you're the consumer, it can change even more. Because obviously, am I installing software on top? If I take a container base image, am I putting my private keys in there? Am I putting API access information in there? Am I customizing it with plugins? It gets very complicated very quickly, but that's okay. We're not going to worry about a ton of the complications. We're just going to kind of go with what we've got. And then why? I think the why is the big one. And prior to, I think, 2025, SBOMs were a novelty to many of us, where we thought this is neat technology. We think they're useful, they're interesting, but they're kind of a pain in the butt, and it's a lot of work, and I don't really want to do it, right? This is one of those situations where everyone will say, oh, yes, I want security. And then you say, I need $1 million. And they're like, our security's pretty good. It'll do. But it's kind of a changing world out there today. So compliance. Compliance is why we're going to need SBOMs. And that's just the simple answer. It's not about security necessarily. It's not about, like, we'll say doing the right thing. It's compliance. And the one to really keep an eye on is over here, the Cyber Resiliency Act. It's called the CRA. This is a thing from Europe. It's going to, I think, change a lot of how we do a lot of software. And the CRA has language that literally says you need an SBOM. Like, it says the word SBOM. It's not like you need an inventory. You don't need an ingredients list. It says SBOM. And they're specifically calling out SBOMs in CycloneDX and SPDX format, unsurprisingly. So the CRA is going to affect an enormous number of companies. And you might say, but I'm not a European company. This won't affect me. If you are selling into the European market, you need to pay attention to this. If you have people downstream from you selling into the European market, they're going to tell you to pay attention to this. Because the CRA doesn't just give you like a blanket, oh, just make an SBOM for your stuff and you're done. They want SBOMs from your suppliers, and then your suppliers will need SBOMs from their suppliers. And it's kind of SBOMs all the way down. So the CRA is probably going to change the way we do a lot of things. Now, the FDA is another one in the US. The FDA has SBOMs literally written into law. So this is like a non-negotiable thing, right? This isn't like, oh, you need an inventory sometimes. Like, you literally have to have it. If you're doing medical device, you're doing kind of medical software, SBOMs are mandatory. There are other things going on. You've got like the United States Department of Defense is saying they want SBOMs. That one is not written into law, so it's not quite as, it doesn't have the teeth like FDA and CRA do. But we're even seeing this in things like, the new PCI. It doesn't say you need an SBOM, but it talks about an inventory of your software. You need an inventory of your software, guess how you're going to do it, right? I mean, same thing like FedRAMP, SSDF, NIST, there's all these things happening. So this is a topic that is going to affect all of us at some point in the near future. Okay, well, how do we get started? Just pick a tool, easy, right? Pick a scanner and run it and you're done. So there's a project I help with at the OpenSSF, the Open Source Security Foundation, that we call ourselves SBOM Everywhere. And we have this thing called the SBOM catalog. I've got the URL down here. And the SBOM catalog has, we'll say, a collection of tools in it. It is not comprehensive. It is not complete. But these are the tools we have. And you can see this is already like an untenable list of things. How do you possibly decide which of these things you want? And this is going to be one of the challenges, is there are a lot of tools, there are a lot of things you might need to do. And so inside of this tool, you have the ability to pick out like certain features you want. Like, I only care about SPDX. I only care about CycloneDX. Maybe I care about both of them. I want to make SBOMs. I want to convert SBOMs. I want to parse SBOMs. Like, there's all this stuff you can do. There's the licenses of the tools, like the actual license the tool is. So you can be like, is this free? Is this commercial? I don't know what this is. There's the supported ecosystems. We've got this huge list over here. So this particular one is for a tool called Syft. And we're going to talk about Syft in a moment, because it is one of the tools I help work on. It is an open source tool from Anchor. It is free and it is very useful. And obviously I'm highly biased, but I think it's the best one. Okay. Now what to scan? This kind of comes back to that salsa picture we had just a few minutes ago. And it's not as simple as just saying, I'm going to scan a directory. I'm going to scan a container. There's a lot of artifacts we generate in like the world of software, right? You've got like source code repositories. You might have virtual machines. You might have like zip files. You can have tar files. You've got your container registry, which is where you store your container images. You've got like a Kubernetes cluster that's running stuff. You might have this stuff you're getting from vendors. So like these are all things you need to think about is what is the thing I'm trying to scan? Again, not every tool can do everything. Like as much as I would love to say Syft does it all, it doesn't do everything. It does a lot, but it doesn't do everything. So this is you have to think about what you are doing in your situation. There's no easy answer. You might have to do some research. You can come find someone like me and I'll talk your ear off about this if you want. There's groups like, at the OpenSSF, we're doing the sort of work of trying to unwind some of this. There's people at OWASP. There's groups all over the place that are trying to help everyone understand this. And I'm sure as we see things like the CRA come into force more, you're going to see even more guidance and even more written about these topics. So it's an interesting concept that is not simple yet. It's getting there. It's getting better. Although maybe it'll get worse as everyone writes an SBOM tool. Okay, so to get started, we're going to install Syft. Now, Syft is a very simple application. It's just a Go binary, one binary, right? We're not talking about like installing this big Linux distribution and putting all these packages on top and all this. It's really small. There's a container. You can install it on your local system. There's like GitHub runners, there's CI/CD integrations, all that stuff, right? But we're talking about functionally one binary. It's written in Go, and so it's nice and easy to install, which is one of the goals of the project, is to make it easy. Because obviously, if something is really hard to install, if something is really hard to use, that makes it more difficult and it pushes people away. So I've got a couple of videos that I'm going to show, and we're going to start with containers. So I'm going to hit play and I'll pause and kind of explain along the way as we go. So if we just want to scan a container, this is kind of what we do, right? We can just say Syft Debian latest, and that's going to scan the container named Debian latest. But where's it coming from, right? Syft has a bunch of different places it might look. It's going to look at your local Docker. It's going to look out into registry. It's going to see if it's on your system. We can find it. So just saying Debian latest might not do what you want it to do, but it's as simple as that. Like you can just type that in and it's going to do what it wants. So we're going to delete that and we're going to say, I want to use my local Docker instance to scan Debian latest. And so now I'm saying I have Docker running on my system. Syft, I want you to ask my Docker for Debian latest. Okay, that's not too bad. Now, though, we can also ask an OCI registry. So we can say, go to docker.io and download Debian latest from there. So now Syft will reach to the registry and it will pull that container in. And we're doing that right now. We're actually scanning it. Okay. So now we can see it scanned the Debian container. There's 78 packages installed, 655 executables, 4,000 files. It's going to give us this nice table output of the package name, the package version, the thing it found. So in this case, most of them are going to be Debs, Debian packages. Makes sense since we're dealing with Debian. But you can imagine if you have Python packages installed, if you have Java jars installed, there's all these ecosystems and there's all this stuff. And we're working especially with containers, you will have a collection of random things. And so it might be a bunch of, Debian packages plus the Python I put inside of it, whatever. And Syft tries really hard to figure out what all that stuff is. Now, I have another piece to this example, which will play. Let's scan the Alpine container. And Alpine, for those of you who don't know, is just a tiny Linux distribution. And so that's going to scan, obviously it goes pretty quick, but now we can see 16 packages instead of 78, right? It's quite a bit smaller. We see kind of the same information. And the point just being, these are just two examples of things Syft can do. Now I'm going to hit play again, and it's going to run for a minute, and we're going to talk about outputting. I talked about SPDX and CycloneDX. This table format is for humans. It's not machine readable. So it has the ability to output, for example, an SPDX JSON file, right? Seems easy enough, makes sense. Boom, we're done. We have a JSON file. That's our SBOM. That's the thing we can store. We can give it to customers. Whatever we need to do with it, we can do with it. I have another example now where I'm going to scan a directory instead of a container. And we're going to create a little NPM project. And I want to kind of explain one of the, I guess, unique challenges of installing software. So we're going to install this thing called Axios, which is just a node package. I picked on it because it has a lot of dependencies, but not too many dependencies. One of the jokes in like the node ecosystem is that you're going to end up with thousands of dependencies. You can see I install Axios, I get 23 packages. And it's like, wait a minute, I installed one thing. So I can look at my package.json file and it shows Axios. I installed one thing. Like, what is going on? Why did this happen? And this is something Syft is really good at. So now instead of a container, I told Syft, scan the local directory, dot in this instance, and then show me what you get. We see it found 23 packages. That is interesting. That's the same thing. That's good. It matches up because sometimes it doesn't. And then you have to ask questions about why are the numbers not the same. But again, we have this situation where it's going to show, right? We've got the name of the package, the version of the package, and then the type. Like in this instance, it's NPM because we're scanning a directory full of NPM files. So this is what Syft does. It tries to go as deep as it can. It goes inside of all the dependencies. If you have like, for Java, jars are especially gnarly because you can have jars inside of jars inside of jars. And it's like jars all the way down. And so this is what Syft does. It tries to figure this out. It tries to go as deep as it can. Now, for outputs, you're going to say, what should I output, right? Syft has all these different formats that it can output. This is actually the list I took from the --help. I just made it look prettier because --help is kind of ugly. But at the end of the day, the formats you want are CycloneDX and SPDX, right? And I even put a little pointer at, I said, use these two. So they do like XML. SPDX is this thing called tag value, which looks like a human readable table. Just use the JSON. And the reason I say that is most of the tools today that are capable of doing something with an SBOM, they are expecting JSON because JSON 1, I'm not going to get into an argument over, JSON versus XML, but JSON 1. Now, there is a format from Syft called Syft JSON. And this is kind of a magical format because what Syft JSON does is you can imagine CycloneDX and SPDX are a little different, as all good standards are. And you can't like convert from one to the other. If I say I have an SPDX SBOM, but I want to turn it into a CycloneDX SBOM, like there are ways to convert them, but you will lose information. They are not lossless when you convert them from one to the other. So what we did with Syft is we created this format we call Syft JSON that's just like the Venn diagram of everything. And so Syft JSON can be converted to CycloneDX or SPDX without losing any data. Syft JSON is not a standard. Do not give it to anyone ever. That is not why we did it. We did it because we needed the ability to output either format or both formats in some cases. So if you're storing them for yourself, Syft JSON has some advantages, but if you need to give them to someone, do not give them as Syft JSON. There are no tools except Syft and Grype that know what to do with these things. So what does an SBOM look like? This is the just output of an SBOM file, right? This is actually from that Alpine image we scanned just a moment ago. And this is what it looks like, right? You've got like some metadata information, it's got package information, and it goes on and on and on. And these files are pretty big. Like we're talking, hundreds of kilobytes, maybe megabytes. There are some SBOMs I've seen that are hundreds of megabytes. It just depends, right? It depends how big the thing you're scanning is, how much stuff is in it, and what you're doing with it. In this instance, obviously, it's the SPDX format. Like, these are not for humans, so I would never suggest you necessarily spend a lot of time in it. However, if you are writing tools and you need to parse these, the JSON is well-formed. It is easy to understand. These are well-defined standards, so you can look up documentation and get an idea of what you need to do. And there are tons of libraries. Like if you're, for example, writing a Python application, a Go application, and you want to parse an SPDX file or a CycloneDX file, there are libraries from these projects that do that. So you don't necessarily have to be the one that's, writing your own parsers and trying to understand the JSON, which is good because they get very complicated very quickly and the standards change. They are both under active development. You will see new versions of SPDX and CycloneDX coming out on a regular basis. So even if you write a parser today, you aren't necessarily going to be able to parse whatever's coming out next. So this is just kind of one of those things as a developer to keep in mind. Okay, there are also some additional Syft tricks that we can do, right? We can obviously output the SBOM to a file, which I showed. You can put the file wherever you want, unsurprisingly, as almost any tool would do. There's excluding paths. Excluding paths, I think, is an underrated feature that is extremely useful. And the example I will use is literally Syft itself. So you can imagine that Syft, the source code, has like a bunch of tests. And the tests are gnarly things, right? This is on purpose because it's anytime a bug is found, you create your test, and the test obviously does something ridiculous, as all tests do. And so inside of the Syft test suite, there are like weird SBOMs. There's weird examples of like applications of like package lock files, things like that. And so if you scan the Syft source repository, it looks like Syft has like 30-some thousand things inside of this directory. It doesn't really. It's full of test material. And so you can imagine that when you scan something with like weird tests or just weird content, you're going to get false positives or false negatives in many instances. In this case, Syft has a huge number of false positives. This is a pain in the butt. So this is an example where, like, if we scan the Syft source code, we're just going to say, don't scan the tests. Ignore that stuff. That's not legitimate content. Now, obviously, after we build the binary, and if we scan the Syft binary, which you can do, you can scan Syft with Syft, which is extremely amusing to me. But if we scan Syft with Syft, like the tests don't get built in, so obviously they're not there. And so we're just going to get a list of what you need. Syft has a configuration file format, right? We can preset some of this stuff. We can preset what directories to skip. We can tell it what output we expect. We can tell it where to store things. These are just handy tools we can use, right? That way we're not having to remember or try to not make mistakes when we type it in the future. You can also connect it, private registries. That's a big one. A lot of us now have our own private registries, be it hosted somewhere else or we're hosting in-house, right? And again, you have to send credentials in, things like that. Like that, it works. It works great. And it's widely used. All right. So there's some next steps we can take as well. Automate. Automation is key in this day and age, right? No one would expect you to run all this every time you do something. So one of the things you can do is like Syft has an SBOM action for GitHub. So you can just say, every time I build a release, build an SBOM. And now the SBOM is part of your release, right? Automatic, we're done. There's a bunch of open source projects doing things like that. Like Python's a good example. The Python project is automatically generating SBOMs now, which is cool. And like humans aren't involved, which is good because humans make mistakes and they sleep and things like that. You can scan an SBOM for vulnerabilities. This is probably the most widely used use case today because obviously if you have a list of software, you can say, what are my vulnerabilities? What are the problems my software has? Makes sense. The cool thing about scanning an SBOM for vulnerabilities is it's really fast. If I scan a great big container, let's say, it's going to take, 10 seconds, 30 seconds, whatever, to look for all the packages. And then it creates the list of packages, and then we scan it for vulnerabilities. If I already have the SBOM, I've already used up my 30 seconds of compute time making the SBOM, and now I can scan it for vulnerabilities, usually in milliseconds. So it's a super cool feature, and I really like it. And it's so much easier because the reality is like SBOMs are static. Like once I have a list of my stuff, that doesn't change. Well, it will change in the next release, obviously, but then I just generate my next SBOM. Whereas vulnerabilities are like the arrow of time continues to bring us new vulnerabilities. So the number of vulnerabilities I have today won't be the number of vulnerabilities I have tomorrow. We're adding, 7,000 a day or something in CVE right now? Like, it's gigantic. And then store them somewhere. Now, whenever people ask me, like, okay, I started making SBOMs, what do I do? And my first answer is like, just put them in a directory. There's tooling you can use. There are applications, some paid, some free, that let you ingest these SBOMs and do interesting things with them, like scan for vulnerabilities. But to start, just use a directory because this is one of those situations where crawl, walk, run. Just start putting them somewhere easy. Eventually you can, put them into your NoSQL database. You can put them in your SBOM management tool. You can use, Splunk and Elasticsearch to extract information. There's all these things we can do. But just start, don't worry about any of that stuff, right? Just start simple. All right, vulnerability scans. I've got a little preview here. This little guy over there on the side, that's the Grype mascot. The Syft mascot was a bird with glasses, many slides ago. But this is an example where I take that Alpine SBOM we made, right? And we can scan it for vulnerabilities. And Grype is meant to be just as easy to use as Syft. We're not talking about Grype today, but I just wanted to kind of show an example where we take our SBOM, we scan it with Grype, we get our list. Obviously, this is a human formatted list. You can output to JSON and various other formats. Some are industry standards. Some are like the Grype made up one that can output into industry standards. You get the idea, right? It's meant to be simple. And now we can take, if we have that SBOM, we can scan it every day and we can look at what the results are. We can store the results. We can ask questions like, what are the new things from today? What are the stuff, what's the stuff I have to worry about? What are the packages I should upgrade? All right. Now, there's also, when we talk about use cases, there are many more use cases than just vulnerabilities. Vulnerabilities are just, I'm a vulnerability nerd, so it's the one I won't shut up about. So other use cases. There is a paper from the OpenSSF, that group I'm involved with at the Linux Foundation, SBOM Everywhere. We published a paper recently. The title of the paper is over here. It's Improving Risk Management Decisions with SBOM Data, which is a mouthful. It doesn't necessarily sound like something exciting to read. It's a very good paper. But one of the things it has is use cases. And obviously, I just grabbed a snapshot. There's many, many pages that detail what this means. But there's more than just vulnerabilities, right? We've got like our CVEs at the top of the list, of course. But then there's things like open source licenses. What are the open source licenses in your application? End of life software, right? Do we know how old some of this stuff is? Once we know the name and the version, we can ask a question of how old is it? Where did it come from? There's, risk assessment. This is turning into a thing where companies will say, give me your SBOM. I want to see what's in your stuff. And you can be like, you haven't updated anything in 10 years. We're not buying your software. Component usage. This is a great one where the idea is how many groups inside of your organization are using Axios? How many are using Log4j, right? Things like that. And so you can be like, okay, we're using 30 versions of Axios. So what if we started using 2 instead? So there's a lot of interesting questions you can start to ask once you start to capture this data. And that's part of the fun, right? There's, incident response is a big one. Log4j was an incident response incident, right? If you had a catalog of all your software, instead of saying, I don't even know what software I have, we could say, let's go see what has Log4j in it. And this is actually something I saw during that was an organization had SBOMs for all their stuff. And in literally like 10 minutes, they knew where Log4j was and everything. It was amazing. It was so cool. But anyway, you get the idea. It does more than vulnerabilities. Now, there's some gotchas in this data though too. Accuracy. SBOM scanners aren't perfect. As much as I would love to tell you Syft is perfect and doesn't make mistakes, it is not perfect. If you run it and you find false positives, false negatives, weird bugs, whatever, like file an issue in GitHub. We want to know. We want to fix it. Our goal is perfection. We know it's unattainable, but that's what we're working towards. There's things we just can't scan right now, right? There's some archive formats that aren't necessarily supported. You're good, like an encrypted zip file. Like there's nothing we can do with that. There are things in the works, and that's okay, right? This is just one, you have to know what you can and can't do. Every tool has limitations, know what they are. There's things we can't see. So one of my favorites is every couple months, someone shows up. It's like, hey, did you know if you delete like your package lock.json, the SBOM scanners won't find anything? It's like, yeah, we know. Don't do that. So there are malicious attempts to hide from an SBOM scanner, which will be successful. It's not that hard to do. But there's still like, there's ecosystems that might not be supported. There's some package formats that might not be supported. So like, it's not perfect. Again, file bugs. We'd love to hear about it. And then converting between formats, right? You can't take an SPDX and turn it into a CycloneDX. At this time, that does not work. It's on the list. They're working on it. But in the interim, this is where like the Syft JSON format can be useful. So there are things you can do. It's not simple. So kind of next steps, this is some Anchor links, right? We've got like a link to Syft here. We've got a nice introduction to SBOM site. That can help with that. We've got a discourse for our open source tools, Syft and Grype. We have a tool called Grant, some things like that. SBOM Getting Started Guide, SBOMs at Scale. Google did a great job of that. They literally scan like millions of these things on a regular basis. Absolutely amazing. So there's a lot of cool content. There's a lot more cool content coming. If you want, come find me. I'd love to chat. I absolutely love chatting about this stuff. It is one of my favorite topics. Most people I know aren't willing to chat about it. So please come and chat. But otherwise, thank you so much. This has been an absolute treat and a ton of fun, and I hope you learned something new today.